In past problems, we've looked at where we start with just products and then it's going to shift to reactants, or we've started with just reactants that then we know it will shift to products. But what happens if we start with some products and some reactants? Where is the equilibrium going to shift? And will it be at equilibrium from the start? And so we need to know what's called the reaction quotient. By finding the reaction quotient, then we can figure out if the reaction is going to shift towards the product side or towards the reactant side. So the reactant quotient is given the letter Q, and it's found by substituting reactant and product concentrations or partial pressures at any point during a reaction into that equilibrium constant expression. This Q helps us determine which direction the equation will shift to reach equilibrium. If we find that that reaction quotient is equal to the equilibrium constant, then we know the system is at equilibrium. If there is too much reactant, then we know that the equilibrium must shift to the right towards the product side. And we know that there will be too much reactant because when we solve for Q, Q is going to be lower than K. If there's too much product, then the equilibrium is going to shift towards the left, towards the reactant side. And we know that there's too much product because our Q value will be much higher than that equilibrium constant. So to sum up, we solve for the reaction quotient. If the reaction quotient is equal to the equilibrium constant, then we know that we are at equilibrium. If the reaction quotient is smaller than the equilibrium constant, then I know that everything's going to shift towards the product side. And if my Q is bigger than my K, then it's going to shift towards the reactant side. So let's go ahead and do a problem where we can find that reaction quotient. And so we basically find Q just like we find the K. So we're going to set up our little ice chart and plug in all the information. And then I'm just going to take the information that's given and find Q instead of K. So I start by just writing my equation across the top and then initial change and equilibrium down on the left-hand side. And let's plug in our initial values. I also do like to separate the reactants from the products, just to keep that clear in my head. So you see that we're starting with some products and some reactants, and we don't know if this is at equilibrium. And so I don't know whether I'm going to have minus x's here or have plus x's here. I can't determine that right now. So I need to write an equilibrium constant expression and solve for Q. So let me just erase those x's because, again, I don't know what is going to happen. All right, so instead of solving for K, we're going to solve for Q, but it's done the exact same way. So I'm going to have C times D over A times B. So let's go ahead and put those values in. And when I do my math, I get 4 over 25. And my value is 0.16. So now we're going to compare to the equilibrium constant value, which we are given as 100. So because my Q is equal to 0.16, then I know that my Q is too small. And because my Q is too small, that it is going to shift towards the product side. So now I know that these are going to disappear from this side and they're going to appear on this side. So I'll have a general shifting there. All right, I'm just going to erase this math here at the bottom so that I can have some room to double check that we've done it correctly. Okay, so now we know which direction it shifts. I'm going to bring everything down. And we're not given any equilibrium values, so I just have to bring it down like this. And let's go ahead and write that equation again. I guess I should have kept it. And plug in everything. So I have 2 plus x times 2 plus x, so 2 plus x squared. And at the bottom I have 5 minus x times 5 minus x. So I'll just write it that way. And we do know what our k is. K is 100. So to get rid of, so to solve for this, I'm going to take the square root. And I get 10 is equal to 2 plus x divided by 5 minus x. And then I just need to do my math. Get all the x's on one side and all the numbers on the other side. So I have x equaling 4.36. So I'm going to take that and put it into this equilibrium line right here. So I end up having 0.46 here. And on my reactant side, I end up having 6.4. Let's just double check that we've done everything right. So again, I know 100, and then solving for that equation again, I should have 6.4 times 6.4 divided by 0.64. And when I do all the math, I get 99, which is pretty close. So this is the answer. Probably just have some rounding errors. So you always can take your equilibrium values and then plug it back in to see if it matches that equilibrium constant. And we did a good job here. All right, let's try another one. Again, we write our equation at the top. Let's try another one. Write the equation at the top. And we have our ice chart and put in our initial concentrations, 2 and 10 and 10. So I don't know which way it's going to shift. Maybe it'll shift to the left. I don't know. So let's go ahead and find that Q. So we'll put in those values. So Q is 25, and then I compare it to what I have. And because K is equal to Q, then I know that I am at equilibrium. So on this case, there's no shift. We're already at equilibrium. Okay, we're going to do our final example. So write the equation at the top. Separate those reactants from the products. Put in what we know. So A and B are 1, C is 10. So I'm going to write that reaction quotient. So C squared over A times B. Go ahead and plug everything in. And I get 100. Let's compare that to the K. So because my K is lower, then that tells me that I have too many products. So it's going to shift over towards the reactant side. So that means I am going to have my products disappear and my reactants up here. And make sure you use the stoichiometry 1 to 1 to 2. And again, that's just from the balanced equation. Okay. Let's bring everything down. So I have 1 plus x and 1 plus x, and this is going to be 10 minus 2x. And I'm just going to erase my Q math here. And let's put in the K. So we have 25. All right, so if you look at this, I see that I have some squares. So 25, I can square root that, and I can square root the whole right-hand side of the equation. And so I'm going to have 5 is equal to 10 minus 2x over 1 plus x. And now I'm just going to do my math. I'm going to do it over here so I have a little bit more room. So on this side, I'll have 5 plus 5x. I'll have 10 minus 2x. Let's get the numbers on one side and the x's on the other side. So I'm going to add 2x to both sides. And I'm going to subtract 5 from both sides. So I end up getting x is equal to 5 over 7. Which is 0.714. And that is what x is equal to. So I'm going to put it into this line right here. So I'm going to have a 1.714 here and 1.714 here. And this one's going to be 8.57. Okay. Let's just double check and see if it's correct. So solving for my k, I'm going to get 8.57 squared over 1.714 squared. And I get 25. So that's our answer. Our answer of equilibrium concentrations is right there, the 1.714 for A and 1.714 for B, and C would be 8.57 at equilibrium.